Okay, in this video, we're not going to really learn anything new here. This is just kind of a tool that mathematicians use, and they do kind of teach us this in the section, and they give you some of the problems in terms of I and j. So basically, I and j are just these two unit vectors, and this would be kind of the horizontal vector from 0 to 1 and the vertical vector from 0 to 1. And we give them the names I and j. I for the horizontal vector, j for the name of the vertical vector. And so let me show you what you can do here. So let's say v here is equal to -3, 5. Now I can kind of take this apart. This is the same as -3, 0 plus 0, 5. See that? And so if you added them together, you would get that. Now what I could do is I can factor out the scalar -3 here, and I would get 1, 0, and I would get 5 and 0, 1. Okay, so and these here are I and j. Okay, so then I could rewrite this as -3i plus 5j. And this is called a linear combination of I and j. A linear combination is just where you have a scalar times a vector plus scalar times a vector. And in this case, any vector can be written as a linear combination of I and j. And it's very easy because basically the scalars here on I and j are just the components, okay, inside for the vector here. So let's just try another one here. So let's say v is equal to 7, -5. Okay, I don't have to go through this every time. This is just kind of showing you here. But if I wrote this as a linear combination of I and j, it would just be 7i. And then I could write it as minus 5j. And it would look like that. Okay, and the idea behind this just is more like an algebra expression, and so then you can kind of do different things with it, and it's just one of the ways that they work with vectors. Okay, and the idea of linear combination is just when you have a sum and a product, or I'm sorry, a sum of vectors with scalar products on them, okay, and they call that a linear combination. And so basically this is just saying any vector can be written as a linear combination of I and j, where the scalars are the components of the vector. Okay, so now we're going to do a couple things with this because they kind of have you do this on the homework. So if you remember a couple videos back, we did these scalar or these vector calculations, and we had these vectors here, and we did these different calculations. Well, what I've done here is I have the same vector written as a linear combination of I and j, and same with here. And I just did u and v just because we're going to just do a couple of different things here, kind of the sort of things you might be asked to do on the homework questions. So what I could do here, for example, is I might have 6 times u plus 5 times v. Okay, and u and v are these. So I could rewrite this 6 times 5i minus 2j, and then this would be plus 5 times -4i plus 7j. And then I'm distributing here, and I would get 30i minus 12 j. Let's see. Did I? Oh. It was, yeah. Okay. I'm trying to say, I was going to show you that it was the same as this, but this isn't the same for some reason. We'll look. But this is okay here. And so then I'm going to distribute the 5, and this would be negative, and I could have a minus here. And so maybe I'll put a minus 20i, and this would be plus 35j. Okay, and so now you can combine, it's kind of like you're combining like terms. And then when you subtract these two, I get 10i, and then subtracting these two, I get plus 23j. Okay, and what I was going to do is I was going to show you that you would get the same thing here, except in this form instead of component form. And the reason I can see what we did wrong now is I did 6u plus 5v, but here, this on here is 6v plus 5u. And so maybe let's do that. We'll do 6v plus 5u, and this is going to give me 6 times negative 4i plus 7j, and this would be plus 5 times 5i minus 2j. And now I can distribute, and this would give me negative 24i plus 42j, and then this would be plus 25i minus 10j. And now I can combine like terms. Combining the i's, I get just I, and then combining the j's, I get plus 32j. Okay, and then what you can see here is you get the same thing. This is component form, 132, and this is the ij form. Okay, and so you can see kind of how this might simplify some of the work, or just it just works different, you know, feels a little different, combining like terms, things like that. And so let's do a couple other things. So let's say I want to find the magnitude of u. So u is 5, negative 2, I here, and so I'm just going to take 5 squared, the coefficient on the I, and plus negative 2 squared, and so then I get square root of 25 plus 4. This is the square root of 29. And then let's say I want to get the unit vector for u, and so what I would do is 1 over the square root of 29 times 5i minus 2j. And then I could just distribute that over, and I'd get 5 square root of 29i minus 2 over the square root of 29j. And you can see then that these are just different ways of doing the same thing. So, along with this idea of linear combinations. So, okay. So now the next video is a very important video that we're going to then use. The videos after that are going to be different sorts of applications with what we learn in the next video.